So hello again, everybody. I'm Mike, co-founder and CEO at Tecton. We have a really cool panel right now. Basically, we've been talking a lot about what makes for successful, what helps teams be successful with machine learning. And I thought we would bring together a variety of leaders in the MLOps, machine learning data space, and hear from them about some of the trends, some of the lessons that they've seen from working with successful machine learning teams. So this panel is really about like what kinds of patterns do these folks see when they are working with all of their customers, all of the teams that they're working with, the most successful machine learning teams. And so quick intros to some of the panelists, and folks, thank you for being here. So number one, Alex Ratner, co-founder, CEO at Snorkel. Snorkel AI, assistant professor of computer science at University of Washington. Hello, Alex. Good to see you again. It's been a while. Secondly, Aparna Dhinakaran. I think I got that right, Aparna. We actually used to work together at Uber, co-founder and chief product officer at Arize, and she has spoken here before. And then, so welcome, Aparna. And so number three, Ketan Umare, co-founder and CEO at Union.ai. Ketan is the creator of the flight project out of Lyft, also created the Flink Kubernetes operator as well. Welcome, Ketan. Good to chat with you again. And then last but not least, Biswaroop Palit. Good to see you again, Biswaroop. He's head of product at Monte Carlo. And he's got a ton of experience managing technical teams at AirKit, Rubrik, AWS. So I think this is a good panel. I'm going to do the least amount of talking, hopefully. And I want to encourage everybody here to just make it a very natural conversation. I've got a couple of questions that I want to kind of kick things off with, but I also am going to monitor the Slack at the same time and kind of pepper in questions that I'm seeing in Slack. So if you have something you want to ask the crew, just put it in there, and I may pick it, and we'll introduce into the convo. So let me just start things off, and I'll ask this to Alex, and then maybe we can go to Aparna. But again, make it a live conversation, interrupt people, go back and forth. But Alex, how do you work with a bunch of teams? How do you tell if a team is successful with machine learning? Like, what defines success for them? There's often a lot of other things for something to get into production that can block a machine learning project, things that are not related to machine learning. How do you tell if the machine learning team is successful, and how should they kind of measure themselves?
Yeah, it's a great question. And I also apologize in advance if you see a look of horror on my face. It's not anything that anyone on the panel is saying. I'm monitoring a little bit of drama on the baby monitor about a
Go get the baby. You can bring the baby here.
Oh, it's okay. I'm the second string here, but I'm transfixed. Yeah, I mean, so one thing I'll note, and it might be an interesting way to kind of break up different segments of the ML world for the conversation is, we live a lot in kind of unstructured, unlabeled data world where it's a lot of kind of 0 to 1 projects, and so. I mean, if you ask for my honest answer of kind of what we look to assess, and this isn't a comment on the quality or the intelligence or the capabilities of the team, quite the opposite. It's kind of the point about being stuck on the data that we see a lot in the wild, and I know you see as well. What's the first thing I look for? I mean, a baseline, a clear understanding of metrics that align with an actual, line of business team or downstream stakeholder. A proper evaluation. I mean, so I think, I think when you're in the 0 to 1 settings, it's a lot of just kind of basic first and last mile stuff. So first mile, maybe, how close are they? What's the status of kind of getting the data, and also getting the data kind of curated and shaped. Often that is, what is the relationship with the relevant subject matter expert team that they are going to rely on to build this problem and often build the data. What is the problem formulation and then kind of last mile, what are the metrics, what are the baselines they're comparing to, and very importantly, how are those metrics correlated with some metric of business value that their eventual stakeholders and sponsors care about. So that may sound very basic and boring, but I think some of those fundamentals matter a ton, because if those are in place, then you have lots of runway and support to build all the fanciest, ML things. And if they're not in place, then, often you're kind of, off in science project land. And that's at least one thing I look for. Again, boring and less technical answer than maybe we were looking for here, but I'll start with that.
That's what I was just saying in the previous thing too. You need some alignment to some business value, and also, even if there is business value, you need it to be recognized at a higher level as well. So you have that executive support for your project. Aparna, what do you think?
Yeah, this is a really good question. To be honest with you, I think about the ML team velocity. How many shots on goals can this team get to get a successful ML project working in production? And, the way I measure that is, well, first, how quickly can you get the model into production? Is this a 10-month-long research project? Is this a 1-month quick turnaround? You have an idea, you want to experiment, and you can throw this into production. Okay, well, how are you going to measure that now? How do you know if what your experiment number 1 is working or not working? And do you have the right tools to measure that and know how to quickly iterate? And, I think there's a lot of parallels to successful ML teams and successful product and engineering teams. Successful product and engineering teams have, try to get something out really quickly, an MVP, but then have tools in place to iterate and accelerate the team. And it's shots on goals for me. Like that's what I look for when I think about a successful ML team is this all talk, or have they built a process in place to be able to try things really quickly and grow from there? Does that make sense?
Yeah, that makes sense to me. Do you think about just the 0 to 1, like this is new project, well, how fast can I get to production? Or do you think once, this was kind of a topic of the talk that I was giving yesterday, but I focus a lot on the iteration speed, even if you're already in production, that ML flywheel. Is that something that you think about a lot as well?
Yeah, that's probably where we sit in a lot, just being on the observability side. I think 0 to 1's one component, but it's the iteration. Like tech is never good the first time you throw it out there, but you got to get something out to then know, how am I going to get the next 5%, the next 10%, the next 20%? So do you have good observability in place to know what to go improve? Do you have good tools to go quickly fix problems? And then how does someone go iterate? Who owns that? What's the process to go fix things afterward? And it's the 1 to 100, being able to iterate quickly, that exact same with, I think, a lot of parallels to the software world. You roll something out, it's an MVP. What's the N+1 state of this tool?
Great. And when I've worked with successful machine learning teams, I have found that they tend to adhere to a variety of, they just have principles. They have their own culture within their team. And so let me switch over to Biswaroop. Biswaroop, when you're working with ML teams, successful ML teams, which principles do you see these teams adopt really at their core? Do they not compromise on? So an example is like simplicity, like just build the simplest thing first. That's one we hear all the time. I think it's a great idea. What other kinds of things might someone be thinking about, or are patterns? And we'll also go to Ketan for this as well.
Yeah. Fantastic question. And, I think one of the core things we observe is, Martin was alluding to this in the previous talk as well, like data quality, or, like building the core data infrastructure is extremely hard. And focusing on data quality, like in terms of reliability, being able to, test the data based on certain criteria, which should be true, observability, as Aparna was talking about. I think those are fundamentals that ML teams really, who are successful, really need to care about. In general, the complexity of data pipelines has increased. The scale of people touching or interacting with your data, doing aggregations and modeling with your data has increased by a significant amount. And hence, processes such as manual tests, such as, being able to just have people-driven processes, those tend to break more easily now. And so having the tooling to be able to enforce some sort of data quality, like quality of your data infrastructure is super important.
So like
That's
automation around observability generally and what's going on in all the data processes.
Yes, around the data pipelines, and then like obviously around the ML models themselves as well. The second thing I think is very aligned to what Alex and you were just talking about, which is like we observe that stakeholder buy-in or like the fundamental business level alignment from the top, that actually helps a lot with successful ML teams, just in terms of being able to understand what is the primary business KPI you are trying to solve for before trying out a bunch of different experiments and stuff.
Awesome. Great thoughts. Ketan, what do you think?
Yeah, I think all of them covered almost all of the points that I had made. But one of the things that I want to say is like, always start with the simplest thing. Sometimes, and anecdotally, I was at the I won't name the place, but I was a place, and one of the teams was essentially, there was an engineering problem. Like data was being dropped. We were losing data. And instead of solving that problem by fixing that pipe, we were applying machine learning to actually solve that problem. And that's never going to be successful. So if you're forgetting,
you're not talking about Lyft, are you? There's no chance you're
I
talking
am not
about
talking about Lyft. No, and I'm not saying about one team. Every team evolves, right? Like teams have to go through this initially. Even within big companies, we've seen that there are teams that are much smaller, which has one person wearing multiple hats. Even then, it's critical to be like to focus on the business metrics, right? Sometimes people don't even put the right metric to measure at the end and start building models, and they're like, okay, how do we know that this model is actually working in production? And so that's how I was like, the metric here was, let's say, get something XYZ right. And they're like, oh, we have 2 data scientists. Let me just, instead of doing the machine learning, I'm going to just apply machine learning models. Doing the engineering right, we'll apply machine learning models right. The other thing that I think really successful teams are doing well is ownership, right? Like it's like, there's this metaphorical wall that happens all the time in large product teams, which has like data scientists and research engineers love to build models in XYZ, Jupyter notebooks or whatever, right? Throw them over the wall. And then engineers are like, okay, what do I do with this? I'm supposed to deploy this. I don't even understand your code. I'm going to rewrite it. That's like almost, you're downhill from there. And then you rewrite it, it doesn't even produce the same results on the same data set sometimes. And sometimes it does, but then in production, it just completely starts drifting, does all kinds of weird things. And I think one of the other aspects is, we are running real-time online services nowadays with models.
Yeah.
Who's responsible for the pager duty at the end of it, weirdly. And so ownership we have to like inculcate in a feeling of ownership across the entire team.
Yep.
Like a model is not the responsibility of the data scientist, neither is the production only the responsibility of the engineer. That somehow we have to create a feeling that folks can work together and we can deliver fantastic outcome for our users, right?
I think your ownership point is pretty interesting because in this space specifically, because it may be that the engineer who runs the production service did not make the model and doesn't even understand what the model does. And it also may be that the data scientist who made the model doesn't know anything about how the production service runs. And so I've always found that it's been tricky to determine like who to say, hey, this is the one person who's the owner right now, the one person who's on call. You really need like a team effort here.
Yeah, it's actually very hard to have one owner. Even in the simplest of problems I've seen, that at least there are 3 owners, right? Maybe 4. There's a product manager too.
Yeah.
So, and then there is a VP or somebody who's sitting and saying, these metrics are not being met. So there are like too many owners, but I think it's a team. It's like, building any complex software system, you have to start saying that it's a teamwork. Now, the hard part over here is that these sometimes the skill sets don't overlap. And as a industry, we have to figure that out, how to make sure that we can do our best parts right and still deliver a complex product for their users, really. So
I got it. Those are really good points. And Sorry, was someone else cutting in to say something?
I was just gonna bring up, I've been seeing this thing across, and there's kind of two tracks that I've been seeing in ML teams. One's where it's kind of like the Uber model that we saw probably, Mike, where data scientists and ML engineers are totally different personas. One builds a model, one owns it in production.
Yep.
And then you see more of the Google approach, right? Where it's this person owns it end to end. And, I think DoorDash even is that approach where it's one person owns it versus you have the split role. I've seen both work. I've seen cases where, you've done the separation roles and it still hasn't worked. But the commonality there, I think, is there's this really key who both of them need to be a part of owning the success of that model in production. If there's that separation of roles, whether it's the data scientist saying, hey, this is the metric that I expected in production, and ML engineering saying, hey, this is exactly what we see, or it falls within some confidence interval of that. But there needs to be that ownership tagged to who owns what and what part of the stack.
Yep. And Alex, I saw you were going to chime in. I wanted to ask you, very related, which development patterns set successful ML teams apart from the rest?
I was just gonna plus one a bunch of those points. I mean, I think that maybe before jumping into that question, I guess I maybe have the cheesy variant of the answer, but just saying that collaboration patterns, in addition to, ownership, we can all own everything. We can have a nice, nice commune approach maybe, but as long as there's collaboration, I think, again, maybe, there's probably a natural correlation between some of the use cases that, we're working on, just basic kind of labeling, development, management of data sets. So often we're more in the 0 to 1 stage, although I wholeheartedly agree with iteration. And that's obviously a key part of what we work on too. But either way, in that stage, maybe I'm asking kind of simpler questions, but just asking a simple question like, and actually this is part of our kind of filtering script when we go out and talk to new prospective teams to work with, who knows how to label your data and measure your model, right? Yep. What team, right? How often do you meet with them, right? How do you get feedback on your model or your data? Or what's the process? Is it a lengthy calendaring process that ends up in a bunch of meetings and some Excel spreadsheets tagged? Are they part of your team and you're rapidly iterating all the time? Do you have a good relationship, or are you begging them for time? The number of ML teams that we talk to who have almost burned bridges with their subject matter expert collaborators who know how to label the data and measure success because they've asked so much of them with so little return. That is one, again, I'm going really simple and basic, but kind of, predictive measure of success, I would say.
It's fascinating to what extent just like a basic collaboration patterns throttle success for an ML team. We have the exact same thing in our sales process where we just have similar questions, not the labeling ones, where that helps us determine, do these people have a basic competency? Like, are we going to be able to help them, or are there far deeper problems that it's not even related to the ML team, let's say, that we're not going to be able to help with?
Oh yeah, if you're relying on some basic, subject matter expert knowledge for whether you're, developing your training data, or you're developing your features, or you're doing observability, or you're doing all these other kind of aspects that we all cover, and you rely on, a counterpart for just answering basic questions about that process, which, I think a lot of folks in real practice, outside of, say, Kaggle data sets actually do, whether they realize it and acknowledge it or not, then your speed of collaboration, going back to that shots on goal or iteration point, is fundamentally going to be bottlenecked by that collaborative loop. So I mean it in a cheesy sense, of course, but also in a very operational sense that it ends up being one of the chief rate limiters of, oh, well, the model's making some errors here, but we're not even sure if that's a model error or a data error. We're waiting for a meeting next week with our, our collaborators, or we're not really sure what, again, every single loop of the cycle. I think that ties into iteration, because if you can make that tighter and you can make the means of communicating that subject matter expertise or domain knowledge, faster, then you can iterate faster, which is obviously, key. I think in terms of development patterns, you touched on one great one to start with, which is start simple.
Yes.
the numbers, not to detour to something that's too specific to what we do, but we often have help users to kind of take more programmatic approaches to labeling and doing other data operations rather than manual. And there's some simple problems where someone can write a program to label data, and then they say, hey, this is actually really accurate. And is that a problem? We say, no, that's actually the point of, especially back in the academic days, why we were trying to develop this workflow, because the number of teams I've seen spend just countless, I was gonna say, ungodly amounts of time on training massive deep learning models, and then later, months later, maybe find out that, hey, a simple regex would have done decently enough. It would surprise you. It's much greater than zero. So whether it's that specific example or other parts of the process, starting simple, first in a really rigorous sense, where you're being very disciplined about avoiding the flashiest new model architecture or technique, and you're taking into account not just a metric, a kind of summary statistic like accuracy, but also qualitative aspects like manageability, auditability, adaptability, et cetera. That's definitely a really important one. Again, often overlooked. I think maybe another development pattern is again, thinking about a lot of the things. I'm just stealing too many of your lines, Aparna, or not exactly. I'm sure I'm not doing justice, but talking about the parallels to software development. And when you start a mature software development process, you think a lot about aspects of just maintainability and governance and adaptability, and you think about exactly kind of I don't know, you just think of a lot of basic things that ML teams often don't. I'm surprised the number of teams that don't think, what happens if again, we work in supervised learning, so you're trying to predict against some kind of annotation schema. What happens if the line of business comes back and they want 10 classes instead of 5? This is just one example, but the number of times that is not asked, and it always happens in any project that even makes it close to prod. So I think thinking about those things from the beginning, rather than just rushing to bump a number up on this kind of summary statistic metric, and then saying, oh wait, there might be other qualitative factors that we have to take into account, and you realize that you're totally unable to adapt, or you're never going to get it through model risk management, or XYZ, et cetera. So I think maybe one last thing to wrap up on.
Alex, sorry to interrupt, but to clarify, is the point that like introducing and trying to like hold the bar on basic software engineering hygiene in projects brings a lot of the other great benefits of software engineering, like flexibility and a lot of easy to roll back your project and a lot of different things like that are not typically prioritized by ML teams?
Yeah, let me try to recast it maybe, and then I'll cede the floor. But
sure,
because I'm rambling too much. But I was kind of phrasing in the sense of I think engineering teams and product teams are better about thinking about this kind of broad set of qualitative factors that are kind of longer term. We're often when we're doing machine learning, I'll include myself in that, and the field, we're often thinking about kind of a score or something shorter term, and not thinking about those considerations enough, and then it comes back to bite you. Maybe one way to put that is that that we are in machine learning, we're both kind of blessed and cursed by this ability to kind of reduce things to summary metrics, right? So if you look at machine learning progress, the advent of kind of leaderboards and benchmark data sets, and chasing a higher accuracy score, that has I think absolutely and undeniably pushed the field forward at an incredibly rapid rate, but it's also been the crutch, because then everything becomes about getting a 1/10 of a percentage point more of accuracy versus all of the broader set of factors that actually matter. So again, another kind of milquetoast in the middle answer, but I think you have to be balanced between the two. Teams that don't have a leaderboard, that don't have a metric, a number that they're able to iterate against and measure and just kind of push up, are not going to succeed. But teams that are too reductive and glued to that number and aren't thinking about the broader set of qualitative factors are also going to fail. So only the teams that have both at every step of the way are going to succeed. And I think that's both in out in the real world, also for academic progress too, for what it's worth.
That's a great point. It's almost as if your applied ML project's objective function is not necessarily the theoretical objective function of the model, right? You have other things you're optimizing for as you're going through the project. And you mentioned a variety of elements around collaboration and Aparna, you were talking a little bit about like team structure. Can you tell us a little bit more about like what types of team structures you see successful ML teams have?
Yeah, that's a good question. Alex, just want to give quick follow-up to what he was saying. A lot of your points, I actually really plus one to a lot of them, especially in the unstructured data field. I think that's one where my point around shots on goal is the loop's even longer because you wait to get data, right? And then you build the model, then you go out there and you're like, well, my model's trying to predict, is this a dress or not? And looks like it's categorizing a bunch of skirts as dresses. Oh, you find that out a couple months later, you go back and label more data. And so even in that case, I see it as, applied ML, your point that you were getting to is like, I think applied ML should actually be much closer to typical product and engineering workflows around getting observability in place, getting tools to help you get 0 to 1 out, and then how do you know how to quickly iterate for more shots on goals so that you can come back and improve that model over time? And it's not about getting your first model out that's the top of the leaderboard, but how do you get to the top of the leaderboard in 10 days or in 10 weeks versus, you're incrementally versus trying to get there all in one shot. Is how I think
100%. Oh, sorry, I didn't mean to cut you off.
No. I just a lot of plus one to what you're saying. And I've seen this go in different ways with a lot of the teams, even we work with. So in our sales process, we see a lot of individual ML teams. So call it teams that own a specific ML use case. Like this team owns the fraud model. And then we see a lot of teams that are called your central ML platform teams. Mike, me and you both came from one. I'm sure there was one at Lyft, Ketan. But we see a lot of these central ML teams. And one thing I've seen, central ML teams that really understand their customers and try to, what are common pain points that all of these lines of business teams are individually trying to solve? And how do I build better structure and process in place so that, hey, you all focus on the ML problem. You all focus on solving that one core use case that your team owns. Is it pricing? Is it ETAs? Is it fraud detection? But some of the infrastructure pieces, let us help take that so that you can improve your team's velocity overall. Like that's actually something I've seen, really good central ML teams reduce the time it takes for a line of business team to deploy a model and make it successful. It's a common practice that I think all ML teams are, a lot of top ML teams are starting to adopt, is who owns the infrastructure behind ML team velocity.
Separating out the use case from the application, or from the infrastructure, sorry.
Yeah, yep. Ketan, sorry, I think you were going to say something.
Yeah, I was just going to add to it because I work a lot with ML platform teams nowadays. It's becoming a norm and it's a good thing. I think what we need to do is push make the product teams nimble. They need to be product teams, and the product teams need to be like these multidisciplinary kind of diverse teams that have data with data science or research with product engineers, right, together. But we need to provide the right tools. Like I'll add a little bit to Alex's point. Like I agree with most of the things they said, but I'm also going to come from an engineering world. Good intentions are not enough, right? It's just, we do have, for collaborating and for making things right, good intentions, sure. We document them, right? As ML platform team folks, we did document, like, you will do these things, you will define metrics, and then people did. But what you really somehow need to be able to do is essentially make those good intentions, codify them, like literally make them part of your process, of your workflow. And some of that, like, I'm sure Vishwarup will agree, is like data quality. Like, don't just wait on data quality being like a thing that people will do. It's just make it as part of, whenever they're developing, just make it intrinsic. Similarly, I think, when you are creating, make the data more observable, or make drift as a possible thing, or, what we've been pushing a lot within our world is understand the boundaries of every step. And then if 2 or 3 folks interact and collaborate, then, and they are on different steps, then, it's like an RPC. Like in software, we have services. We don't know what the intricacies of that service internally are, but we look at the interface and it just kind of works. And like Google Maps is a service that 4,000 people behind it. I don't care. I'll talk to it. I ask it for a geolocation, and it gives me that. And we kind of we need to get to that simplicity of like being able to crisply define what the semantics of something are, and then potentially that part is owned by that one individual or one team or whoever it is, and then allow people to. And that's where I say, intention not enough. We need to have codify these systems. But sorry to interject over that. I just wanted to add like this.
Awesome. Well, again, I want to remind people, if you have questions, toss them in Slack. There's a question from Miles from Snowflake. And he said, and this is, anybody can chime in and take this, obviously, many data science software companies, so companies represented here, have identified that companies, your customers, often lack internal resources to really own the success of the ML projects. And so then those companies end up hiring customer success managers to help them from the vendor side, so it's like if your team hired a CSM, a customer success manager, to really help out your customer. And so the question is, for your companies, what do you do to ensure that your customers' ML projects are really successful? Is it an approach of like, let's hire someone to be the kind of like person who's there, that's their partner? Are there other processes, other things you're looking out for? You're being more selective in which customers you're taking on. And then I think what may be really interesting is if you can also kind of compare that to what you imagine might be useful for like a platform team internally to think about as well, because they have their own internal customers, and a lot of the audience might be represented by platform teams. Anybody want to take that? Tell us how you're doing success, Alex.
I think Aparna beat me in the quick draw.
Oh, really? Okay. I saw
honest.
Biswaroop too.
Oh no, take it.
Yeah, I can talk a little bit. So actually, like, customer success is something, again, like coming more from the data infrastructure side, right? Like one of the things that we have noticed is successful teams tend to really treat their data, their ML models, etc., as products themselves. And I think like this paradigm, like while it sounds vague, it actually has a lot of implications around the cultural aspects of different teams collaborating. So, to Ketan and Alex's earlier points around ownership and collaboration, like if you think about the data producers versus the data consumers, and then like the people in the middle, like data engineers, ML engineers who are managing all of this, if you start thinking about your data and your ML models as products, a lot of clarity is driven on who owns what. And like, while good intentions are generally seen across the board, like the identifying the central owners becomes a lot more clear with this model. Then coming to the specific question around customer success. So while, a few things that our customer success teams do is, one, we understand certain dimensions of our product really, really well across, the multiple customers that we have deployed, and like we have, renewed over the course of the years and stuff like that. So based on that, we have developed a central playbook around onboarding customers, around helping them deploy an observability platform across their core infrastructure, how to configure their alerts and their notification channels to bring down the noise, to avoid alert fatigue and stuff like that. We have these playbooks for, essentially data quality best practices that have been codified into what we call the Monte Carlo method. And we run every customer through that as they are onboarding onto our platform. And we have found that that has been extremely, extremely helpful in like setting the stage and then like letting them take that initial onboarding step and constantly iterating on top of that to eventually arrive to better data quality. So you don't start day one with these are the SLAs and SLIs that need to be met for these particular data assets. You start with like the broad best practices on maybe the most critical aspects of your data, and then like you keep iterating from there.
Awesome. Awesome. Okay. Well, I think we're at time now. So very interesting conversation. Thank you for sharing your insights on all of these topics. Very cool. Ketan, Bishwaroop, Alex, Aparna, thank you so much.